Good morning, everybody, and welcome in. We're happy to have you here. Everybody have their coffee? Yeah, we're kind of awake? Okay, ready for day two. Please welcome to the stage here this morning, kicking us off from Sophos, Peter Gordon.
Thank you, and good morning. So yes, I'm Peter Gordon. I'm a cloud security architect with Sophos, and as you can possibly guess from my accent, I'm actually from Australia. Today I'm going to talk to you about how you can secure the traffic leaving your VPCs on the AWS cloud. Often security focuses on traffic coming in from the outside, but it's also very important to make sure that you secure traffic going to the internet as well. Now, for those of you who aren't familiar with Sophos, we're a global cybersecurity vendor, and we've been around for over 30 years, and we've worked with AWS since 2011. In fact, we were also one of the first security vendors to achieve the AWS Advanced Technology Partner Security Competency. Now today I'd like to share a story with you about one of our customers and the solution they deployed in AWS to secure their outbound traffic. Now this customer is a large multinational, and they had several data centers around the world, and they made the decision that they were going to close them all and in the process migrate everything into AWS. So their designed architecture in AWS was going to cover multiple AWS regions and VPCs. And for a variety of regulatory and compliance reasons, they had a need to control and have visibility of all outbound traffic from their VPCs. So this meant they needed a variety of security controls, including stateful firewall, network address translation or NAT, web content filtering, and also transparent proxy. Operationally, they had requirements around high availability, auto-healing, and auto-scaling. And with paired VPCs, there was also the need to somehow send traffic across VPC pairing connections and out to the internet securely. So the limitation of transitive pairing also had to be overcome. And lastly, because of their DevOps requirements, the solution that they were going to select ideally needed to be deployed via code, so infrastructure as code. So the solution that our customer adopted achieved all these requirements and more. It consisted of a small cluster of Unified Threat Management Appliances, or UTMs, deployed in a gateway type VPC. Now these UTMs were deployed using AWS CloudFormation, which was great because that supported their deployment via code requirement. Once deployed, these UTMs were then configured to provide the various security controls required. Firstly was the ability to control and log all outbound traffic by using the firewall function in the UTM. Network address translation was also used to prevent internal IP addresses from reaching external servers. And the web filtering functionality in the UTM allows it to actually examine a requested website, look at the category that site belongs to, and then make a decision as to whether or not the internal EC2 instance requesting that site should be allowed to get to it. And with that, transparent proxy was used, so the company was able to avoid the need to set the explicit proxy within their EC2 instances. To allow the UTMs to control traffic originating from within paired VPCs, the second component of the solution was to deploy what we call outbound gateways, or OGWs. Within each of the paired VPCs. Now these outbound gateways are EC2 instances, and they're deployed with CloudFormation. And because they're EC2 instances, they can be used as targets and route tables. Now to pass traffic to the UTMs for filtering, the outbound gateways established GRE tunnels with the worker UTMs, and the worker UTMs are the ones that handle traffic going to and from the instances. And the other thing about these GRE tunnels is that they can also go across VPC pairing connections. So with the outbound gateways and the UTMs deployed, the next step was to configure the route tables for the internal subnets so that they would use their nearest outbound gateway as the target for any traffic that was going to the internet. So when an EC2 instance, or for that matter an AWS workspace, tried to connect to the internet, their packets are sent first to the outbound gateway, then through the GRE tunnel to the UTM workers, which in turn inspect the traffic and determine whether or not it should be allowed to go out to the internet. And if it is, it's passing it out to the destination. So to put that into a picture, this is what the deployment looks like with a single VPC. So at the top of the VPC, we have an internet gateway. And then immediately below that, we have a controller UTM. This is like the brain. It's where we do all the configuration on the UTM cluster. Now that configuration is then stored automatically in an S3 bucket. And in the other AZ, we've got a subnet which basically is empty, but we can deploy a replacement controller in the event that the existing one fails. And that's done through an auto-scaling group. At the same layer, we also have what we call these worker UTMs, as I mentioned previously. So they're handling the traffic going to and from internal instances. Now, these workers, when they launch, they obtain their configuration from that S3 bucket that I mentioned automatically. So they can basically be automatically configured at the drop of a hat. And below the UTMs, we have at least one outbound gateway per AZ. Okay, once the outbound gateways are deployed, they will then establish GRE tunnels with each of the worker UTMs. And below the outbound gateways, we have our internal subnets containing our various EC2 instances. Now, the subnets internally have route tables which will have a route entry for 0.0.0.0/0, and where the target is the nearest outbound gateway. And finally, if the nearest outbound gateway fails, the route tables can be updated automatically to point to the outbound gateway in the other AZ. So we can achieve some high availability through this as well. So next we look at extending that outbound gateway deployment across paired VPCs, which is the design adopted by our customer. And in the paired VPC, there is a subnet where the outbound gateway is deployed. Now, the route table for this subnet contains an entry for the pairing connection, which enables the outbound gateway to establish the GRE tunnels with the UTM workers. Then we have one or more internal subnets, and in this case, we've got one that contains AWS workspaces, but it could easily be other EC2 instances. Now, the route table for this subnet contains an entry which, of course, points to its nearest outbound gateway. Now, when a workspace's desktop or EC2 instance tries to connect to the internet, the packets are sent first to the outbound gateway, then through the GRE tunnel, which is going over the pairing connection, to the UTM workers, and then out to the internet. So this is how the solution is able to overcome the limitation of transitive pairing. So what were the outcomes? As a result of the solution adopted by our customer, they were able to achieve the following outcomes. Firstly, the overall solution was able to be deployed using CloudFormation, which supported their deployment via code or infrastructure as code requirement. By using outbound gateways, the overall design was simplified, which significantly reduced the number of UTMs required. And initial design included UTMs in each VPC. So that was going to significantly increase the cost and complexity. So by using outbound gateways instead, the UTMs were only required in one VPC, which was the gateway VPC. The UTMs were able to be configured to provide the various security controls required, and in doing so, achieve the governance requirements. Resilience and self-healing were achieved as the solution uses AWS CloudWatch. So if a UTM was to fail, a replacement one would be launched automatically in its place. And auto-scaling was also used in the solution so that the worker UTMs, if they started to come under excessive load, they could auto-scale, get the latest configuration from that S3 bucket, and handle the increasing load, either going in or coming out. And finally, one other benefit of the solution is that it can also be used to support ingress traffic if required. So having said that, what I'd like to do now is show you a short demo of how quick and easy it can be to deploy an outbound gateway. For this demo, I've built a single VPC environment with a private Windows instance behind an auto-scaling UTM deployment. So you'll see we're looking at some EC2 instances. We've got a Windows instance there, and we've also got some UTM instances. You'll note down on the bottom right where we're looking at. So what I want to do as a part of building a new outbound gateway is look at what's the subnet routing at the moment. Okay, so if we have a look at the subnet that the actual private instance is stored in, when we look at the route table, we'll see that it doesn't actually have any actual entry to the internet. So it's got a VPC route, and that's it. So that's going to make it quite hard to actually get to the internet if you've got no route. Now, I've set up an HTML5 VPN through the controller UTM into that private instance, which you can do with the UTM solution. And what I did originally was just try and get to a couple of sites. Tried to get to Wikipedia, couldn't get to that, and then also try and get to Amazon.com. So I'm going to launch another tab, type in Amazon.com, and after a few moments, it's going to say, sorry, can't get there. Come back later. So this page can't be displayed. Okay, understandable. So next thing I want to do is look at my web filtering policies. So I've got this list down there which shows me the subnets that are allowed to be passed with the UTM. So the subnet is the internal subnet AZ2. It's 10.15.22, I think. Check the policy to make sure that all categories are allowed. Then jump back to the dashboard and just see that the web filtering is enabled, but it hasn't had any requests because we're not pointing anything to it just yet because we don't have an outbound gateway. So what we need to do now is create an outbound gateway. Now, firstly, the first thing we do is we need to create a profile for the UTM controller to authenticate with AWS. Well, there was already one there because I'd pre-built it, but just checking was fine. Going to the gateways, I go new outbound gateway. I'll give it a name, so reinvent AZ2. Then I need to say which particular subnet am I deploying this outbound gateway into. Now I need the subnet ID, so I'm going to go back to AWS. I'm going to go into my subnets, find the subnet that I've created for that particular purpose, the outbound gateway, copy the subnet ID, and then I'm going to paste that into the field there. Next thing I need to do is say to that outbound gateway, these are the subnets that you're going to be responsible for. So it's going to be that internal subnet AZ2. And then I say, what particular size? I'm just going to run a T2 small. We'd often run like a medium size one in production. They're Linux instances. They don't have to have a lot of resource. Click Save. Now what's going to happen is the controller is going to call AWS CloudFormation and launch a stack. So initially it says, waiting for stack ID. If we then jump across to AWS again and then open up the CloudFormation console, I'll just hit refresh and it will show my new stack launching. So the controller has initiated that stack launch, which is why we need the credentials within the UTM. It takes about 5 minutes for this to launch, so I've just skipped ahead there. So that's great, the stack's there. And it's deployed this new instance called Load Balancer LB. Now that's sitting in that middle tier subnet, which is the outbound gateway. So the outbound gateway has been deployed, which is great. Now we go back to the internal subnet, and we'll have a look at the route table again. So there's no internet entry. Now for the purpose of this, we do need to create a dummy rule, which will be overwritten by the outbound gateway when we enable it. So I'm just going to use the internet gateway as the default target for the internet. But this, as you will see, will be overwritten automatically when we turn the outbound gateway on. So back to the UTM, do a quick refresh, and we should see that the stack's finished, which is great. Flick the little switch to enable it. It takes a few moments to establish, and then once I refresh, it shows as up. Okay, so that's good. So far, so good. Double check in the dashboard. We'll see there's an additional interface showing. It's called EGW0. And the state is up and the link is up. So it's all good, but there's no traffic going through it yet. Okay, that will change. And when we refresh our route table, we can see that the route for the internet's been updated with the ENI of our load balancer. Now, just to be certain it's the load balancer, I copy the instance ID, go back to EC2. I'm going to filter on that particular ID. And hey presto, it's that load balancer LB instance. Right, so far so good. Now for the acid test. See if we can browse to the internet. I'm just going to refresh my Amazon.com page. Great, I can see Echo showing up. So I can now get to the internet from this instance. Okay, also couldn't get to Wikipedia earlier. So I'm going to try and get back to Wikipedia, hit refresh, and sure enough, Wikipedia is now accessible. So that basically means that the Windows system can go through the the outbound gateway to the UTM for processing. Now, I want to check that against our logs. This is the web filtering logs, and it's showing entries based on the requests that I've just made. Okay, so they're just going to keep loading as additional objects load on those pages. Right, so that's good. And we can go back to the dashboard, and hopefully we should see some traffic coming through. So yes, we've got a little bit of traffic coming through the tunnel to start with, so we know it's functioning correctly. Now, I always like to double check what happens when you turn things off. Things should stop, right? So ideally, I'm going to turn it off and then try and go back to Amazon. Now, let's have a look at what we've got under Echo. So click on the Echo, show $100 off. Can't be displayed again. Okay, so I've turned the outbound gateway off and I can't get to the internet any longer, which, bit of a shame. So we're going to go back and turn that on because that's what we're going to need. So switch it on, refresh it, it's showing as up once more. Back to our instance, and we'll just hit refresh, and we can start to see some various Echo products. And we can browse around and then, buy whatever we like. Okay, so this applies to both EC2 instances and also Workspace's desktops. So that's how quick and easy it is. So that concludes my session. If you are interested in seeing another demo of the Outbound Gateway in action, you can visit our booth, which is just there, at 3 o'clock today, tomorrow, or Thursday, when Byron from our team will be running a live demo of the Outbound Gateway in action. And if you've got any questions, feel free to come over and ask. I'll be there. So please come up and chat. Otherwise, thank you very much.
Thank you so much, Peter.